Hello everyone. In this video, I would like to discuss regarding the exploring distribution. It is often useful to visualize the distribution of a numerical variable, and comparing the distribution of different groups can lead to important insights. Visualizing distribution is also essential when checking assumption used for various statistical tests, and sometimes we call that initial data analysis. So in this video, I will showcase uh, by using the diamond data, which comes from the ggplot2 package, which you have already seen in the previous videos. So we already know how to visualize the distribution of data by dividing into bins and plotting a histogram, right? So let me load this ggplot into memory and let me build that one histogram. A similar plot is created using the frequency polygon, which uses the lines instead of bar. So this is histogram, and the next one is the frequency polygon. So this uses the line instead of bar to display the counts in the bins. And an advantage with frequency polygon is that they can be used to compare groups. Example, diamond with different cuts, or without visiting. Right? Let me run this one. Let me zoom it. So it is clear from this figure that there are more diamonds with idle cuts than diamonds with fair cuts in the data, and the polygon have roughly the same size, except the perhaps for the polygon for diamond with the fair cut. And in some cases, we are more interested in the shapes of distribution than the actual count. And uh, density plots are similar to the frequency uh, polygon, but shows an estimate of the density function of an underlying random variable. So these estimates are smooth curve that can be scaled so that the area below them is 1. So let me close this and run the density plot. Zoom it. Yeah. So from this figure, it is clear that low carried diamond tend to have a better cut, which wasn't obvious in the frequency polygon. However, the plot does not provide any information about how common different cuts are. Use density plots if you are interested in the shape of variable distribution, and frequency polygon if you are more interested in the counts. So let me close that. So let's improve the smoothness of this. All right. So what I've added the color with respect to the cuts, and the bandwidth 0.2, and alpha the transparency of 0.2 again. So this looks much better graph. Next is we want to see. So there is one more uh, package which is called ZZ Grid, right? And this what package this package do? Let me run this graph. Yeah. So it will divide for each different variable for each category and create a separate section for it. So let me zoom it. As you can see, for each category, the each graph has been created here. We close this one. Next is the we'll use the ggplot again on the caret, and we'll create the bandwidth of bin width of 0.01 and limit it to limit the x axis to 0 to 3 only. So this particular line is do that. And as we can see, the diamond with the caret values that are multiple of 0.25 are more common than the others, right? And let's move to the next part. So here, what I want to do, I want to extract information for a histogram with a bin width of 0.1. Means each bin will have 481 values. So let's create a histogram. In this, I'm making plot as false and putting into the different variable, different object, that is caret underscore br, right? If I view this, it has 6 variable, and if you want to double click and view this, so breaks, count, density, mids, and xm and equidistance are the variable available in this one. Let me close this one. And next, what we are going to do is create a category for each unit. So I'm again that adding into the existing data set as a new variable is caret underscore category, right? Let me run this and run this. So you can see that new caret cat uh, underscore cat, that category has been added. So what we want to do, we want to calculate compute the mean of each bin, and let's do that. So we are going to use the aggregate function here. For data is again diamond and the function is the mean. And if we try to plot this, it gives an error, right? And that is an expected error because so error says the error in xy dot chord xy lengths differ, and that error message implies that the number of the bins and the number of means value that have computed differs. But we have just computed the mean for each bin, haven't we? So what's going on? So the reason is by default aggregate ignores group for each group first. There is no value when computing grouped summaries. So in this case, there are a lot of empty bins. There is, for instance, no observation in the 4.99 into 5. So if we open that, so as you can see, the observation is 272, but we were expecting 481. So that was the mismatching. So we can solve this in different ways. One way is to remove the empty bins. We can do this by using match function, which returns the position of the matching values in two vectors. This match function for these values, and if you use this with the bin from the group summary, the vector containing all the bins, we can find the index of the non-empty bins, and this requires the use of the level function. So this is the code. Let me just run it again, and if I plot this, now we can see it is creating the plot. Let me zoom it, right, and let's add some lines for 0.5, 0.7. If you want same thing, we can do with the ggplot. So this I'm creating a data frame uh, and here running the same graph. So in this it's appear there are small jump in the prices at some of the 0.25 marks, and this explains why there are more diamonds just above these marks than just below, right? The above example also illustrates three crucial things regarding exploratory data analysis. First, plot in our case the histogram often lead to like new questions, right? Why there is a change in the data, and often we must transfer, summarize, or otherwise manipulate our data to answer a question. And sometimes these are straightforward, and sometimes this mean deep dive into our code which we have written. Sometimes the thing that we are trying to do does not work straight away. There is always a solution though, and often more than one. The more you work with the more problems you will learn. So let's move to the next violin plot. It is again one of the alternative to the box plot. I personally like box plot a lot. It's widely used in the industry. So let's create a for using a diamond data set between the cut and price. Let's create a box plot. This is how it's going to display. And for similar, if you are going to use violin, so if you run this, it will create this one. And let's add the quantiles of 25, 50, and 75%. Right? We can update. We can fill this color with the category color, right? So here idle represent yellow and the purple represent the fair. What we can do, we can also combine these two box plot and the violin uh, graph into one. So this is the code what it does. So we are creating using this data set first, creating a violin, then creating the box plot. And legend, we are removing the legend here, and also uh, making it the horizontal, right? like this. Let me zoom it. Yeah, this is pretty good chart. Also, what we can do, there's a package called Patchwork. What is that? It will combine the multiple plots into the single graph. So let's create two plots. So plot one, again, this is nothing but violin, and this is the for the carrot, and this for the price. And let me load this Patchwork. If you don't have, you can install this. Install package and Patchwork, and where I'm just combining this plot one plus plot two. Sorry, let me run this. I plot. Oh, sorry. Yeah, now it is there. So let me click on zoom. As you can see, both two different plots are representing into this single one. And let's create a couple more. For this is for the cut and depth, and this is for the carrot. And here, what is this pipe symbol do? Plot one, plot two, and plot three are will be in the same row, and plot four will have the separate row like this. Let me zoom it. So this is a pretty good looking plot. There are three different plots in the first, and the larger one is the. So patchwork is the package you can use to combine multiple plots. Yeah, this is it for this video. Thank you.